Okay, hello, and welcome to this eCampus News webinar, Leveraging AI to Manage Today's Intelligent Campus. My name is Kevin Hogan. I am the Content Director for eCampus News, and I am happy you're joining us today for what I know will be a very insightful and important conversation. This event is brought to you by Ruckus Networks. Today's commercial and industrial environments demand more from their networks, and good enough connectivity is never really good enough. That's why Ruckus Networks designs and builds truly purpose-driven network infrastructure that meets the strictest requirements of all kinds of environments. Ruckus Smart Campus technologies support everything that elevates reputation: academic excellence, student experiences, research, revenue, and more. A Ruckus network also helps administrators and IT manage sprawling campus operations more effectively, from reducing utilities and facilities costs to safeguarding people, property, and information. Together with their dedicated go-to market partners, they enable customers to deliver exceptional network experiences to the students, staff, and others who count on fast, reliable connectivity, making Ruckus Networks one of the most trusted brands in the business. Now, before we get into our conversation, I'd like to take a minute to go over some of the features of the platform that we're using. This event is being recorded, so you don't have to worry about missing a thing. Within a few days, you'll receive an email message that contains a link to the recorded webinar, along with a PDF of the slides. If you have a question or a comment for us, there's a chat function that you can launch. Feel free to use this feature to contact someone from eSchool News team if you're having a technical question. But otherwise, I really encourage you, if you have a question or comment, to hand them over to me and Terry. It will really kind of help us guide what you want to know and hopefully get those insights to you. So with these housekeeping items out of the way, let's get started with our conversation. First of all, introduce Terry Chow, Global Vice President, Market Development for CommScope. And Terry leads the company's vertical business development teams, focusing on integrated technology solutions across CommScope's various business units. With over 30 years of industry experience spanning both networking and mobile broadband, Terry is often recognized for his depth of knowledge in the tech field. In 2021, he was selected as a Power Players in Venue Technology by Sports Business Journal for his work in large venues. He also represents CommScope across several key technologies, including digital distribution antenna systems, say that 5 times fast, wired and wireless networking, as well as copper and fiber connectivity infrastructure. He is a subject matter expert on digital transformation and its business impact on traditional industries, and is a frequent speaker, panelist, and blogger on this topic. He's a graduate of Northwestern University with a BS degree in economics and attended there on a full athletic scholarship for wrestling. There you go, Terry. That's all we needed to know and more. But our focus today, obviously, on AI. It's a subject matter that I have to say, at the risk of dating myself, is probably the most explosive that I can remember since the turn of the century when it comes to education technology, and maybe technology in general. I won't go way back, but some of my first articles were on will email work in corporate America? So that was like the beginning of the internet. And but over the past 12 months, just the topic has just really exploded, and obviously, especially when it comes to education. So which is why you're all here to listen to this conversation, and I know Terry's going to help us out. And again, before we dive into the weeds here, we have a few questions we wanted to ask the audience just to kind of get a temperature on where you are. Ellie, if you could post that first poll question. So what is your top issue as someone who's on the staff of a campus IT department? Is it maintaining a stable network, secure network infrastructure, managing the increased demand for high-speed internet, balancing limited IT budgets, dealing with the proliferation of personal devices? And yes, my guess will be all of the above. So we'll give you all a few seconds to answer that. Terry, first of all, thank you for joining me today. I really appreciate it. And thanks for putting together these poll questions as well. I mean, it's just, these are all topics that you I'm sure you see in your day-to-day work, right?
Absolutely, and that's part of the reason I wanted to just get an idea if all the above is generally what our audience is seeing as well.
Yeah.
I think it's hard to choose just one of those. And maybe in some cases it may be one.
Yeah.
But the good thing about it is that I think our topic today can hopefully address all of those.
Absolutely. And as we wait for those answers to come in, which they will over the course of the hour, Ellie, why don't we post the question number 2? This is just kind of like a general quiz for everybody to kind of get an understanding of where we are. And I know this is one of the key points that I want to talk about when it comes to the hype of AI versus the realities of AI and what that means for higher education. Because again, as I said, education is really at the forefront, I think, and in higher education in terms of the ramifications of what these technologies mean. So what is the difference between AI and ML? Are they the same? Both terms referring to the same technology? Is AI a subset of ML? Is ML, and Terry, when we say ML, we're talking machine language.
Machine learning, yeah.
Machine learning, sorry, yeah. So
So
machine learning being the broader field encompassing those technologies, or is machine learning a subset of AI? Or are they all completely different concepts? That's an interesting question to throw out there and see what our audiences have to say about that. And again, Terry, I mean, I think it's just once we get the vernacular down, once we get the acronyms, education is so famous for all of its acronyms. I think that really goes a long way in just kind of in terms of establishing a base understanding of where folks are when it comes to installing these sorts of technologies, right?
Yeah, no, and I think one of the key reasons why I wanted to ask that is, there's been a lot of, I guess, FUD, fear, uncertainty, and doubt around AI and ML and deep learning and everything. And I think part of that FUD is not understanding exactly, are these things going to take over and kind of become cognitive in terms of its intelligence and start to do Terminator type of events, Skynet type of situations. But asking those questions, I think, will help us understand a little bit more that actually it's more nuanced than that. It's not it's not left to its own devices where they just go and program themselves.
Right. And so, Ellie, we have one more poll question I think we want to throw up, and then we can really kind of get started. And I see the results are coming in as well. But yeah, I know the one thing that was freaking me a little bit was the idea of hallucinations and AI hallucinations. That's where I was like going into Star Trek mode and like, wait a minute, what are we talking about here?
Yeah, we'll discuss all that stuff too, especially in the language models when you're asking them to create, certain things.
Gotcha. Okay. Well, apparently, audience, you're off the hook. I was incorrect. There was not a third question. So we have these two. Terry, I think we were right with poll question number 1, 73%, all of the above. And then getting into, A was kind of the top of those. And then with question number 2, it was about 46% to C versus B. So that seems it would be the two different subsets between, what is a subset of what, right? So maybe we can get started with a little bit of a lexicon check here when we talk about AI and where that is in terms of an umbrella term, or you give us your breakdown on all the various acronyms.
Yeah, so AI is a kind of umbrella or a more encompassing field in itself. And machine learning is ingesting data and learning from that specific data set. There's another term known as deep learning, which is now interrelated between machine learning and almost mimicking the way that the human brain learns, and it's actually woven, interconnected. between different fields, different subsets, different analysis. But it's really interesting to from a data science perspective and big data analytics perspective to understand machine learning actually can learn and actually can write programs based on what it learns or write certain algorithms based on what it learns. Deep learning is more what we call neural networks, where they're actually, again, mimicking the way the human brain interrelates to various technologies and various data sets.
Gotcha. And, again, to kind of clear away some of the hype, in actuality, a lot of these technologies have already been in place, right? I mean, you have a lot of campuses where, maybe it's been accelerated during the pandemic. Maybe that's kind of affected that, but really, I mean, it's not a question of if or when we're going to use it. It's how, right?
Yeah, well, AI has been around since the 50s, right?
Yeah.
It was coined, artificial intelligence was coined way back when. I think the net of what you say is, yes, AI has been around, but it's been somewhat limited in terms of its data set. I think from a timing perspective in the industry, we went from, wired networks to TCP/IP networks to wireless LAN. And then we had this big surge in cloud and automation where we said, okay, on-premise isn't going to give us scalability, isn't going to give us ease and compute and things like that. So we started putting that in the cloud. Now, during that era, we have always had big data analytics. So the data has always been there. We've been collecting data, having that data set. The big difference now with artificial intelligence, machine learning, and neural networks and whatnot is that it's the convergence of all that. And the key to that is that big data piece, right? So, if you take a look at the Ruckus access point, it used to make decisions based on its own, just within the access point and what it sees. Now, with cloud and the convergence where it can pull not just within the network across other access points, but you potentially could have unlimited networks that you're pulling from. And then so you analyze that data, and then on top of that, that's a lot of data. But with the compute power, you can consume, dissect, correlate, and ingest all that data in near real time. Right. And that is really I think the big difference now is that the data sets are larger. So there we can trend and we can correlate that information. We can do things like anomaly detection and all those sophisticated type things. Where before we've always had that data, it's just a lot of data and no human can actually decipher that data quick enough versus a machine learning system or artificial intelligence system consuming that data.
So I'll presume that has a major effect on network loads, right? I mean, to talk about, say, the difference between managing a network in 2023 and in anticipation of managing a network in 2026 versus, say, 2013 and 2016.
Well, I think the biggest thing, if you look at it, and McKinsey did a study back in 2016, right? Before the big AI revolution that we're currently in, which is really accelerated from the pandemic perspective as well. But what you find is about 43% of IT staff time, based on their study, was spent on troubleshooting, right? And if you calculate that from an economic impact, you're looking about $45 billion, and that's in 2016 money, right? So that's 8 years ago or 7 years ago. So the impact of troubleshooting and trying to figure out what's wrong with the network is a lot of the headaches that an IT staff has, right? and it has a significant economic impact. So what I would say is that going forward from a couple of years ago to how networks would be managed in the future, intelligent network data and artificial intelligence on how you manage that network isn't a option, it's an absolute necessity, because we've got to free up 43% of that lost time. And I think that's where the major impact is. So going forward, there is no reactionary, or we try not to be reactionary, because troubleshooting historically is all reactionary, right? A client says I can't connect, or I can't, I'm in the network, but I'm getting problems with this application, or I can't do my work. Then help desk responds, IT responds, and then the big race comes to try to figure out what's going on. Right.
Yeah, I'll talk a little bit about in terms of the management of the network, and I don't know if this is a technology question or more just kind of a business management question. But when it comes to higher ed, and when we're talking about the use of AI, you could have a place, a university that's doing some heavy duty R&D research, right? And they might have their own, I'll throw out another acronym that I'm still trying to figure out, the LLM, the large language models, to where you're kind of doing some deep research. And then over here, you might have the marketing department in the back office, putting together, campaigns for next year in terms of student recruitment. Are those both the same responsibilities to the folks who are on this call, and do they have to think about AI differently when you're looking at different applications across the university?
Well, the different applications has different requirements, whether that be latency or bandwidth, or some applications are not absolutely critical from a timing perspective. Maybe if my email doesn't arrive for a minute, depending on what's in that email, it may not be as relevant as this video call that we've got, right? So applications have different requirements of what key performance indicators, certain SLAs and KPIs that they have. And I think if you poll people, their applications are always the highest priority application, right? So,
of course.
But I think, if we go back to kind of the reactionary part of how IT departments have operated, where a end customer calls or a problem occurs, then, how do we solve that with AI? And I think, the big evolution here is, can the AI system, with all the data and monitoring that it's doing in real time, can it detect it? Can it get to root cause and make a recommendation to remediate it, right? And that is really kind of what we call the path to autonomous networks, where the network is doing the anomaly detection. It can trend it over time. It can take a look at the potential root causes, because not only has it seen it before in this network potentially, but it's seen it before in 100 other networks, and it's fingerprinted this specific trait that's occurring, and then it's running all the various configurations to remediate that, and it makes a recommendation of, this is the way this is the root cause, and there are 3 potential fixes to it. This is the one that it's recommending as the highest probability, and that's really kind of to me, that's the holy grail of how networks should be managed going into the future, is that it's cognizant of what's happening. It can define it based on a much larger subset. It can run those subsets and those configurations, and then it can make proactive recommendations. And I'll take it a step further. It can proactively make the recommendation, and it knows what, if those recommendations are made, what the end result will be, right? Based on the calculations it's taken in. And correlated against a much larger data set.
Right. So, I mean, at the risk of getting meta here, I mean, it sounds like the use of AI application in network management.
It is network management, but it also, you could say network deployment and network optimization, right? So I really think the management of it is where we lose a lot of the productivity. But there's data to be harnessed in terms of how would we design networks, based on the information that we're gathering on the analytics over time. One, maybe an access point placed here may look good from a modeling perspective, but AI tells us something different based on what historically it's seen, not just in that location, but what it's seen in hundreds, thousands, hundreds of thousands, millions of other deployments. And that's one of the things that is so exciting about it, is that it's not just doing this small subset. And I don't know how many people saw the latest Tom Cruise movie, Mission Impossible. I went to see it when I think the Saturday after it opened, and there's without ruining the plot for anyone.
Yeah, no spoilers, Terry. Come on.
No spoilers, but there is a AI theme to that. And it's really cool to kind of see when you're in the business, to see that kind of theme in a movie, and saying, well, that may be a little bit stretched, but there's some possibility of outcomes that is being calculated there.
Yeah, and it's interesting segue into another question I had when it comes to responsibilities of our audience members in their roles. And I guess that's about managing user expectation and managing user behavior, right?
Mhm.
So, I mean, because this phenomenon has kind of taken over all of us and everyone's talking about AI. And when I think about some of the more traditional aspects of higher education, and maybe even not so much the students, but faculty members who are like, well, this is the way I've always done this for 35 years.
Yeah.
Why am I going to change that now? I guess they all had their first big shock in March of 2020 when COVID decided that everyone's going to be remote learning and teaching. But now here's another example about it. Can you talk a little bit about where, from your point of view, where those responsibilities fall on our audience members when it comes to introducing what AI is, how it works, and how it affects the way that faculty are going to teach and students are going to operate themselves?
Yeah, I think there's a lot of misunderstanding about it. Again, I think people kind of think it's this self-thinking system that's going to go rogue on us someday. What I find in terms of speaking to people who utilize technology within their field is that they just want assurance that what they want to do is actually going to work. And that's easier said than done, obviously, right? When we grow from one device, now we've got 5 different devices. Some of it might be machine to machine or IoT related stuff. That puts a stress on the network. If anybody says, no, I knew before we went to lockdown that my network could handle it, right? Because we've run those models already, and we understood where that our network resilient enough to adapt to that. That would probably be a little bit of a fib, right?
Yeah.
We didn't know any of that stuff, and that put a tremendous strain. So I think from an expectations of users, one of the things that AI can really support is really around network assurance, because with AI, you could actually tell it to simulate the load or an application with various loads and certain test scenarios. And this is one of the things that I think is exciting as well, because there's a lot of standardized testing. There's a lot of application requirements, whether you're in a lab working or you're in a study hall or what have you, a conference lecture location. How do you, an IT director, or how does someone know that when it's loaded with 500 devices or 1,000 devices, or let's say tens of thousands of devices in a general area, that the network would actually perform. And that's one of the things that can be simulated to really give more of assurance. And because I think for most people, that as long as they can do their work and not have to worry about the underlying technology, I think that is their biggest. They don't know in many cases. They may not even be able to spell IP, right?
Right.
As long as they can get their work done, and I think AI and the ability for it to simulate and compare and simulate that load and give that kind of assurance we should save a bunch of headaches for both IT and the end customers.
So once you hit the coveted 5 nines in terms of reliability, it becomes invisible, and that cranky professor just goes on about their business.
It could be that, but the other thing that it could simulate is different device types, right?
Mm-hmm.
So one of the things we generally get, a lot of times people say, how do I know when I need to upgrade, right? Because that's a capital expenditure. That's a fairly loaded question, right? There's a lot of variables that go into it. But let's say you're on an older technology. Let's say you're on Wi-Fi 4 or Wi-Fi 5. How do you know when to go to 6 or the forthcoming 7? Well, we can actually tell you through the trending and through the connection and the data and the visibility that a year ago, your device types were iPhone 10s, but now 40% of your users are moving are iPhone 13 or 14 or whatever the latest and greatest is. And based on that, it has this radio or that radio. So then, as you upgrade or make that capital investment, that there's client devices that will benefit from it. And I find that's the upgrade question is always one of those that rear its head, because networks are client devices connecting to a network to get work done, and it's a little bit of a chicken before the egg in many cases. People want to be future proof, but they don't want to. And that's a funny term in itself, future proof. But a lot of people want to make sure that the investment they do make in infrastructure, they can reap the rewards right away. And sometimes it may not even be device type. It may be, hey, we're seeing saturation, approaching busy hour.
Right.
And now it's time for, and may not just be the WAN network. It may not be a segment of the network itself or a subset of somewhere in the network. And all those things can be a great part of just capacity planning or network planning, network upgrades.
No, another phrase that came about during the pandemic and seems to be not going away is the idea of high flex. So when everything went remote, now we're back into whatever hybrid means. And I know in the higher education, depending on the institution, that could be an all or nothing or somewhere in between. Is that another challenge when it comes to connecting devices when you're looking at that? You just mentioned the wide area network, but like a local area network, and then maybe a student who's out off campus?
Yeah, I think that there's a lot of unpack on that one. One is, how do you want to manage the policies that you may have? Does it go home? We see this a lot in primary education, maybe not as much in secondary education, because for the most part they're adults, right? But in primary education, when we send students home, do the policies that we have in terms of safe internet and access to internet, do those become part of the responsibility of the districts or the university itself, right? Because it's an extension or flexibility for them to do this hybrid model. So we saw that early on in the pandemic. We actually saw it's somewhat sad, but it wasn't the availability that was the issue. There was gigabit Ethernet, and it was the affordability issue that was happening. So we had to play in terms of some of the what we call community-based networks that would extend from the school system out, and that's in a lot of cases that's in partnership, not just from K-12 with the cities, but there's colleges that were participating in that because it was impacting them and as well. So, and now the infrastructure bill actually has what's called anchor institutions. So it provides funds for an internet pipe or an anchor institution like a university or a library or something like that, and from there you could extend out. And with that, we saw the challenge there was, what is the policy, but then how do you manage that? How do you manage these kind of dispersed and diverse networks? And the preference is that you can manage that centrally. You can manage that from anywhere, right? And I think that's also one of the advantages of AI and ML and what we do in that space. For those who are not familiar, it has to be cloud, right? It has to be cloud. There's not necessarily an ML machine or appliance that we put in, even if you take a look at the language models of things like, and I hope I don't trigger, but like the Alexa or the, they're connected to the cloud in order to process all that. So that is one of the, I think, key advantages too, is that when you're talking ML and AI systems that are doing all this, it's really a cloud first or cloud only in this case.
Gotcha. When you talk about that too in the cloud, I mean, there are different network security and data security issues that pop up here, right? Can you talk a little bit about that and maybe how there are new responsibilities and new aspects of network management when it comes to the security?
Yeah, so there's different levels of security, obviously, but in terms of the cloud piece, for us to sell a lot of our cloud-based stuff to higher education, we work with several certification companies. One is a state ramp, which certifies that it follows the best practice and it's secure before it actually could be purchased and procured at a state level, which, many cases, the higher education here in the United States, they're state-based agencies. So it has to clear through that. But there is a lot of, I wouldn't say hoops, but there's definitely check marks and safeguards that have to go, you have to have encryption, has to be secure. You're not allowed to harness the individual data and things of that sort, of personal data. But yeah, that's a concern, and it should be a check mark for people looking at cloud-based systems, in terms of just making sure that the necessary safeguards and best practices are in place in certifications, and that it's being endorsed by agencies like State Ramp.
Yeah. Now, the other big acronym that starts with A in the education space right now is AR and VR. I mean, there's sort of other devices that are going to be kind of part and parcel of whatever these new education learning experiences are. I'll assume that's you're talking yet even more data. You're talking about even more of a network load. Maybe talk about some of those challenges.
Yeah, so we see so AR and VR right now, their primary interface is Wi-Fi. right? We don't see cellular connected AR glasses, maybe in some niche, manufacturing or something like that, where but even in those cases, I mean, those are all, it's not either or, it's usually both. But it's devices, it started out with computers that then went to laptops, then it went to tablets and mobile devices, and now it's going to things, glasses, things, light bulbs and projectors and everything else in between. But AR and VR, we're starting to see it in terms of improving the overall teaching experience, whether it's a field trip, a virtual field trip, or what have you. But the challenge with those is when you get to things were not necessarily, for various reasons, cost being the primary driver and complexity being another one. They don't have enterprise grade security, right? So they may not support 802.1x certificates, for example, where you can't secure that device, or somebody brings it in, connects it to a Wi-Fi network, but wants to connect it to your 802.1x secured network, and that becomes a security risk. So we have to do some fancy workarounds that still provides a balance between usability and security. And some of those may be that, using the MAC address of the device and providing a unique, what we call a dynamic pre-shared key, or a pre-shared key that's assigned to that specific device. So if they gave out that pre-shared key to another device or another user, that other device can't get on the network. So balancing a pre-shared key simplicity with some element of security, and then it comes down to how do we take it to the next level? Not only do we secure that, but we want to segment that network. We don't necessarily want that IoT device, in case it has some virus or something in there that starts affecting the entire network. So then it gets a little more complicated. But one of the challenges currently is people will put it into a VLAN, and that's fine, but it affects devices and users within that logical segment. How do I do it where each device has its own segment? And the industry, fortunately, is moving to support that in what's called VxLAN. So we basically put some fancy headers in front of a VLAN, so that now we can have millions of VLANs as opposed to 4,000.
Gotcha.
So that's a roundabout way of saying, yes, those are impacting. Where we are seeing that, though, since I handle other verticals, they're starting to proliferate themselves more of a G-cool type of situation, as opposed to, because you don't necessarily want to be in a classroom with everybody with glasses on, right? Or goggles, right. Can't see each other. We are seeing it more around training and maintenance, and things like that, where maybe you've got a trade school, and the instruction gets delivered through the augmented reality glasses, where you say, okay, this is where the alternator is, that bolt right there. And it can actually, it's a combination of both augmented reality with artificial intelligence. So it can image it, and it knows that image corresponds to its database of images, and then it could highlight what you do and what the next set of steps is. So we're starting to see that, which is kind of it's an offshoot of AI, but it's in a school setting, I guess, to a certain extent, or academic setting.
And we're starting to slip into Star Trek territory again.
Yeah.
That's
Yeah.
some pretty
Uh,
wild stuff, right?
Yeah, I remember 2 decades ago when now I'm aging myself too. We were just trying to get broadband DSL lines, and one of the debates back then was between ATM, and I'm not talking about the cash machines, but
Yeah, yeah.
basically for those who are a little bit older, um, asynchronous transfer mode, or ATM versus IP. And one of the applications we were talking about was um, when it becomes a stream of data in zeros and ones in an IP network, you could have a virtual assistant, say, record this. And that was so pie in the sky back then.
Right.
Now you can just call, Siri or whoever, and tell it to record the meeting or the call. So
Absolutely. Well, to go back a little bit to when we were talking about faculty expectations, and let's talk about the students a little bit and how that affects the network. So unlike the faculty, I think, and especially because of their experiences of being educated remotely, either full-time or at least partially the last couple of years, the expectations for that network to be up are high,
yeah,
right?
yeah,
When it comes to the students. A
yeah.
recent statistic I saw that when students are looking at schools and looking at universities, whether they're doing it remotely or even when they're walking on campus and trying to get information and going around, that their activity through the web and through their use of chatbots and other AI tools has a really big impact on whether they are going to choose a place to go at all. Talk a little bit about, is that another different kind of layer that an IT administrator has to think about in terms of, I don't know, access to the networks and what, passwords and getting in and
Yeah,
security?
it's a borderline to me between utility and amenity. You can look at it is a utility. Everybody needs it's just like water and electricity and everything else. But it's also an amenity. So what we do see is um, you know broadband and wireless LAN becomes a game changer for the student experience um, at the residence location. And then when they come on to campus, they want that kind of experience extended. One of the challenges that higher education has is that usually they live in residence halls, and they're not expecting, they expect it to be kind of a managed service, or just like they would get electricity or plumbing and what have you. It's interesting, 5 years ago, they didn't care, it started the trend, they didn't care about cable TV, right? They wanted Wi-Fi, because with Wi-Fi comes all the over-the-top services that they would want. And then in addition to that, gaming and gamification has been such a big piece. And then on top of that, it becomes IoT, because everyone wants a virtual assistant that they're used to at the house. So then the question is, how do you actually do that? Certainly you put access points throughout the residence halls. And what would be better is if you could segment, similar to what I was describing before, the individual personal area network that's on your own virtual VLAN, so I can actually be inside, and that could follow me anywhere on campus. So you can imagine, from a recruiting and from a competition perspective, not just having broadband, but having unique things that network can do. A follow me network, really. I could actually be on campus on the same VLAN as I was when I was in the residence hall. And usually those are, two separate networks. One's a residence hall network, one's a campus network. But what if I could, because I could segment that network using VxLAN, allow you to have those individual experiences and have that network follow you. So I could be on VLAN 192 and that follows me wherever I go. So so we're starting to see that sort of implementation where it becomes really a recruiting and competitive advantage. The amount of things that students do that is all based on a mobile device or a tablet, or IoT now. How do they get that IoT device without seeing 5 different devices? How can they only see and broadcast up to their TV? Because all the TVs are smart TVs now, right? And that's actually from a school system. About 4 or 5 years ago, one of the big challenges is hey, we need a student to present in a small group setting. They need to present up to a LCD board, but that LCD board is on the faculty network. So then they put all the LCD boards on a kind of a third rail, if you will, network. And then it's secured differently, right? So all of that, how can I go across those and still maintain security, right?
So that's due to it's really the advancements in access protocols that would enable those crossovers.
Well, that's more of on a logical network, but fortunately, we have gateway functions that are built into our access points or into the switches that can filter and access. But the other way that you could do it is through that segmentation that I was talking about. You have to define what that policy looks like. What is it you're trying to achieve, and then you just map it to the feature set. But the key thing for people to take away there, we've solved those things, right? So it's things we may not have considered if we weren't necessarily involved, but those are kind of the things that you want to rely on somebody who's in a specific segment on a vertical, because they've seen it before, they've accounted for it, they've put it into the feature sets. And then the access protocol stuff, I mean, we're kind of in a transition phase right now where Wi-Fi 7 is right around the corner, and Wi-Fi 6 and Wi-Fi 6E, which is 4 times the capacity in terms of bandwidth spectrum that we have, but it's not usable as much as we'd like, primarily because the devices haven't caught up. And then, I get asked a lot in terms of should I hold off? Should I move forward? And that's again, that's a loaded question. There's a lot of things to consider there. But everyone's situation is a little unique. Depends on what vintage of access you've got, and what the data is telling us in terms of needed capacity and things of that sort. But I'm really excited. I think the industry is going to start announcing some enterprise grade access points very soon. And Wi-Fi 7 will bring in some key features that will make Wi-Fi 6, or what was promised in Wi-Fi 6 and 6E, much more usable in terms of reliability and efficiency. And that's going to be exciting, because it'll actually reduce our latency, and it'll actually increase our resiliency, because for the first time, we've been doing this on the cellular network for a while, but for the first time, Wi-Fi can have multiple links at the same time, and that's something we haven't had yet. So on the cellular side, we call it carrier aggregation. On the Wi-Fi side, where it's called multi-link operation, where we have multiple links enabled at the same time. Where historically you're only connecting one radio at a time, we can now connect multiple radios across spectrums.
Okay.
So
Going back to our first poll question, where the answer was all the above in terms of the challenges and the needs. As we get close to the top of the hour here, maybe give some recommendations to our audience in terms of maybe making a priority list as they begin to start this strategic plan going forward.
yeah, so the best practice first, I think you need to kind of, and hopefully everybody's done it. They baseline where they are. A lot of that is gathering the data and then really coming in and taking a look at, you know, a much longer plan and what tools are really required to do that proper planning. You know, we talk about AI and all, a bad design or a bad, you know, if we're not designing at the base level based on a set of KPIs and SLAs to address certain requirements, no AI in the world. I mean, you know, it can fix a lot of the logical stuff, but on the physical front, you know, we've got things that didn't account for. So you definitely want a list of specific applications and where, you know, your priorities there, and key tenets of what it is you're trying to achieve, and a lot of that should be done collaboratively across different stakeholders. It should be anyway, and then from there, you know, really go out and take a look at the various offerings. You know, we've got great stuff. Obviously, I think we do. But you know, we're not going to have everything for everyone. And there's, you know, you should take a look at you know, all the different options that are available out there.
And when you talk about in terms of strategic thinking, I mean, this conversation has been great because, I mean, it's been forward thinking the whole time. I almost feel like we've been speaking in the future tense a little bit, but maybe I'll get into it a little deeper with you, where take a look at the state of play of higher ed and AI in, say, 2 or 3 years. Like where do you see, what are the steps that our audience needs to be taking in order to be ready to meet those goals going forward?
Well, I think, you know, it has a unique situation where it's going to elevate all of our day-to-day to a next level, right? One of the things that AI people are afraid of is that it's going to replace people's tasks and things like that. And I would say it will replace the remedial tasks that you may not want to do. So one of those things that's concerning is that AI can write its own code. It can actually program and write, you know, Python or whatever, you know, so it's like, is programming really necessary? And I kind of equate it to thinking of it more as you go from a tactical job description where you're having to do specific tasks to being a manager, right? Because we know managers don't do tasks, right? No, I'm just kidding. But
It's all about delegation.
It's delegation and review, right? But AI could do these specific things faster. They can, you know, do it, but it isn't always foolproof. And you talked about some of the hallucinations and stuff, right? So it makes stuff up. If it can't find it, it starts to make stuff up, right? And that's a part where I think the human factor, because AI can't really. Have you ever heard Siri tell you a joke, right? It doesn't have the context and delivery piece, so it does lack that human factor. So I think, you know, in terms of looking at AI, there are elements of the human interaction that can't be replaced, right? The reading between the lines, so to speak. And so I would say that AI will be revolutionary in terms of some of the things it does, like the language models and the image recognition and help us there, but it can't replace us because it can't become human. And that, that is that I'd say is the part that we have to keep in context.
And as long as the campus networks continue to increase their loads and deliver 5.9 reliability, maybe we won't even need to talk about it anymore. It will just be there. It will be baked into everything that we're doing, right?
Well, I think, yeah, absolutely. And I think AI can help us or in terms of everybody's being asked to do more with less, right? So there's no decrease in capacity that's going on. There's no decrease in devices. There's no decrease in security. There's only decrease in funding, headcount, resources, right? And that's where, things like Ruckus Analytics, it really is it's almost a full-time employee or multiple full-time employees that actually is working on your behalf to drive toward that 5.9s. And predict when things potentially will break, or and hopefully remediate them, or if it does slip by and does break, it's going to tell us not just what broke, but why it broke. And that to me is some of the things that we need to harness this technology to really help to do more with less, because that's usually the theme I hear in IT and in universities, IT.
Well, I think this is a great way to wrap up. I really think you landed on the sweet spot there in terms of how this all-encompassing topic right now into all of our lives can particularly affect the audience that's here today in terms of the management of networks in higher ed, and not only just kind of the nitty-gritty of the protocols and what it needs in order to operate, but also some of the behavioral things that need to happen in order for these things to continue to accelerate and work. So I'd really like to thank you today for this really informative conversation, Terry. It was really a great call. And I'd like to thank all the audience members for joining us as well. As a reminder, you'll get an email within the next few days that contains a link to this recording along with the slides. Thanks again for participating and have a great day. Terry, thanks so much.
Great. Thanks, Kevin.